Hello, everyone. In this video, we will continue to examine the processing for the acceleration due to gravity lab, moving forward from your processed graphs. So I have both my process data table, or at least the first part of it, and my graph at this point with the maximum and minimum gradient lines plotted. Now, it's important to record in your lab the gradient values that you have acquired from your linearization. Notice I am simply expecting you to estimate those best fit lines within your error bars, and it's never going to be quite perfect, okay? So this would be within the range that would be totally reasonable as an estimate for the maximum and minimum best fit best fit gradient lines given this data. As a result, my maximum gradient here, I'm going to record as 0.34 seconds squared per meter. Notice that unit. My best fit gradient would be 0.27 in this case. My minimum gradient would be 0.21. Notice I'm intending to significant figures there. And then my uncertainty on the gradient itself, okay, my uncertainty on the gradient itself would just be equal to my maximum gradient minus my minimum gradient, okay, divided by 2. And I'd want to make sure my formatting on this was hunky-dory. Let me go ahead and do that. And great. So we have an uncertainty on the gradient. We have the max and min gradients and my best fit gradient. And you can see that I've got an extra significant digit on my uncertainty on the gradient, meaning that if I wanted, I could go back in and restore the best fit gradient value from before. Okay, so, but this is totally fine. I've got my uncertainty on the gradient and the max, min, and best fit gradient as shown. Okay. Then, in a process, hopefully you can sort of work through for yourself, we need to use that gradient to get the acceleration due to gravity. That is the purpose of this lab. So, in order to do that, we're going to recognize that the gradient is equal to 2 divided by the acceleration due to gravity. For that, I invite you to look back at the notes, and we'll go over it in class. But to find that calculation then, my minimum acceleration due to gravity will actually be due to my maximum gradient. Why? Well, I'm going to insert that formula here. This is equal to 2 divided by my maximum gradient, okay? And that will give me my minimum value on the acceleration due to gravity. I can get my calculated value by doing the same calculation for my best fit gradient. And I can get my maximum value by doing the same calculation on my minimum gradient, okay? And that gives me sort of a measurement for the acceleration due to gravity of 7.4 meters per second squared right here, a minimum value of 5.9 and a maximum value of 9.5. My uncertainty on the value of G is then equal to my max divided by my min, minus my min divided by 2, and that gives me my raw uncertainty. Nope, don't want that. And that'll give me my raw uncertainty, or my absolute uncertainty, on my value of G, okay? And this is sort of a funny bit of formatting here. I've got this set up so that the plus minus shows up, and then this is bolded. All right. Good stuff. Why is that not bolding? Really should bold, but that's sort of doing something funky here. I don't really know why, but we're good. All right, so this is our uncertainty, plus or minus 1.8 meters per second squared, and therefore my final value is 7.4 plus or minus my uncertainty. Okay, so I'm gonna grab my plus minus symbol right here and record this. So this is my final value for the uncertainty on, for the acceleration due to gravity and the uncertainty on the acceleration due to gravity. I then need exactly sort of 2 more things, all right? I need the percentage uncertainty on my value, certainty, and I need the percentage error. And remember, those are different things. So the percentage uncertainty is the value of the uncertainty represented as a percentage, okay? Represented as a percentage. And so I have all the things I need for that particular measurement right here. The percentage uncertainty will just be equal to the uncertainty, okay, 1.8 meters per second squared, divided by my calculated acceleration here, okay? And then what I'm going to do is format that as a percentage, okay? And when I write it up, I'm going to want to make sure I have that as sort of plus or minus 25%, okay? Plus or minus 25%. If I really want to, I can insert that directly into the value here so that it is shown. Well, I don't know if there's an easy way to do that in Excel. Sometimes Excel, I suppose I could mess with the formatting, but I think it's fine as 25% here, just so long as when you represent it, all right, you will want to make sure that you show the plus minus, okay? To show the plus minus. We're going to do the same thing in the percentage error table here. To calculate the percentage error, remember that is the percentage deviation from the literature value. In this case, the literature value is 9.81 meters per second squared. And so what I would like to do to calculate that is to take my value and subtract the expected value, which is 9.81 meters per second squared. That's my literature value. Could also show that in the table. I'll do in a second. And divide by the literature value, which is 9.81. This is going to give me a value with a percentage here. And you'll notice it has a minus sign in front of it. Keep the minus sign. So your chemistry teacher might disagree in this front, but I want you to keep the minus sign. The minus sign tells you that your value of the acceleration due to gravity in this analysis here is less than 9.8. So that minus sign tells you a lot. Finally, I think it might be useful to show that literature value. So I'm actually going to copy everything down just a little bit, maybe just one here. And I'm going to have to mess with the formatting. Undo all of this, just so it's clear. My apologies. And it is also yelling at me because I've moved the value without adjusting sort of what it's referencing here. So this is just the percentage uncertainty. It's the uncertainty divided by the acceleration due to gravity. And this was the percentage error. So instead of 825, this is 824. Should be good to go. Great. And then I can add a column here that's the literature value, perhaps a row. Let's do it right here. The literature value for G, and that's just the value I'm using here is 9.81 meters per second squared. So I'm going to grab this unit, drop it into this format, and I've got to format it to be superscript. But otherwise, we are basically done here. So again, pay a little bit of attention to the formatting, make sure everything looks good. But yeah, this is how you do the processing. And ultimately, you know, you will then need to write this up carefully in your conclusion, and you will need to show each calculation, but we will cross that bridge when we come to it.